Welcome to the second module of how to build chatbots. In this module, we'll discuss one of the three components of a chatbot, namely intents. Conceptually, this is how a chatbot works. The user enters some text, the chatbot thinks really hard, and then a response is issued to the user. Now that's very, very high level and doesn't tell us much, of course, so let's see more in detail how this works. The chatbot will use three main components to determine how to interpret the user input and how to respond to it. Intents, the subject of this module, entities, which we'll cover in the next module, and finally the dialogue, which we'll cover in Module 4. When you create a chatbot in Watson Assistant, the first thing you do is create a dialogue skill, which will contain these three components. Intents are the most important component because they try to determine what the user wants. What are they asking for? In other words, they capture the intent or goal of the user. For example, we could define a greetings intent and train Watson with some examples of what a greeting looks like. We might provide hello, hey, hi, good morning, and for our friends from New Zealand, kia ora. It's a good practice to provide at least 5 examples per intent in order to fully train Watson on the intent. But the more the merrier applies here. Once Watson is trained on the intents we defined, it will look at the user input and try to determine if any of the intents match the user request. For example, if the user were to say aloha, Watson would recognize that it's a greeting akin to the ones we've trained it on. Note that aloha was not one of the examples we gave it. This is where Watson's artificial intelligence capabilities really kick in. We train it with some examples, and Watson will be able to recognize an intent in the user utterance, even when the user phrases it very differently from the examples we provided. As mentioned in the previous module, in this course we'll create a simple chatbot for a fictitious chain of flower shops. So let's consider for a moment a domain-specific intent, as opposed to simple chit-chat intents. Users may want to find out about our hours of operation, so we could define an hours info intent. Note, however, that intents cannot have spaces, so we'll simply use an underscore instead of a space. And here are some examples that we might provide to train Watson on the hours info intent. What time are you open until? What are your hours of operation? Are you open on Saturdays? And so on. These are all realistic ways in which users might express the same request for hours of operation information. It's important to train Watson with realistic examples to the point that you'll even want to leave in typos you might accidentally make as you type out the examples. After all, if you made that typo, your users might as well. Now, when the user asks, "When is your Toronto store open?" Watson will recognize our hours info intent, even though, again, this particular phrasing was not part of our examples. Watson was smart enough to figure out what the user wanted now that it understands what hours info represents. Intent examples can be entered manually in Watson Assistant, but they can also be imported from CSV files. This simplifies collaboration. For instance, you could receive the examples from a colleague in your customer care team who doesn't know anything about building chatbots. To help you out, Watson Assistant also comes with a content catalog, which provides collections of intents relevant to various industries such as banking, insurance, and e-commerce. It's not a pre-made chatbot by any means, but you can use it as a starting point to build upon. It's worth noting that in this course we'll build our chatbot in English, but several other languages are available as well. So if you wish to create a chatbot in Italian or Japanese, you'll simply create a dialogue skill in that language and then train Watson with relevant examples in the same language. That's it for the theory around intents. In the rest of the module, you'll go through the labs that will guide you through the process of creating, importing, and testing intents. Welcome to the third module of how to build chatbots. In the previous module, we mastered intents. This module is entirely dedicated to entities, the second key component of our dialogue skill. As you know by now, intents capture the user goal. Entities allow us to capture specific values within the user utterance. You might recall this example from the previous module. You'll notice how the chatbot is correctly detecting the intent, but completely ignoring the specifics of the question. In other words, when is your Toronto store open and when is your Vancouver store open are the same as far as our chatbot is concerned. That's because we haven't defined an entity to capture that specific bit of information, namely the location of the store. So what we could do is create a location entity. Notice how we use an @ symbol rather than a pound symbol for entities. We can then define multiple values for our entity, such as Toronto, Montreal, Vancouver, etc. One value for each store location that we have. You'll notice that we can also define synonyms for a given entity value. These can be dictionary synonyms, but are often synonyms in the sense that the user might refer to the entity value in that way. Imagine, for example, our Toronto store is located on Warden Avenue. People might ask about hours of operation of our Toronto store, or they might phrase it as, "What are the hours of operation of your Warden Avenue store?" Either should lead our chatbot to detect the same entity value. Synonyms are optional, but are a useful feature and worth defining when applicable. With our location entity defined, we can now detect the intent and the specific location. With these two pieces of information, we can provide an appropriate and specific answer to the user. Note that although entities' values can have spaces in them, we need a special syntax to represent them. If the entity value has a space in it, we simply wrap it in parentheses to refer to it when, later on, we'll define the rules of our dialog. Much like intents, we can also import entities from CSV. In fact, in the labs for this module, you will import them in this way and learn how to export them to CSV as well. Other than entering them manually in Watson Assistant and importing them from CSV, there is also a third way to add entities to your chatbot. In fact, there are some predefined system entities that you can enable if needed by your chatbot. As you can see, there are quite a few options. Syscurrency allows us to detect mentions of currencies within the user input. Sysdate, mentions of dates. For example, the user might reply to a question with next Monday, and sysdate will allow us to capture that piece of information as an actual specific date. Sysperson allows us to detect common names, an easy way to collect people's names to make your chatbot more personal, as you'll see later on in the course. System entities are quite handy, and they are constantly being improved upon. Make sure you check the system entities available in your dialog skill before you jump right to implementing your own entities. All right, now it's your turn. By now, you should know the drill. In the rest of this module, you'll find a series of guided exercises that will teach you how to work with entities. You'll also find some graded quizzes. In the next module, we'll see how to put the intents and entities we defined to good use to provide accurate and specific responses to the user. Welcome to the fourth module of How to Build Chatbots. In this module, we'll finally address the third component of our dialogue skill, namely the dialogue itself. The dialogue component allows us to issue a response to the user based on the basis of their intent and the specifics of their request, which we captured through entities we defined. It's great that our chatbot can detect and classify the user input. However, so far, we haven't really replied to the user at all. We must be able to act on that correct classification by issuing an appropriate response. When a user greets us, for example, we may want to reply back with, "Hi there, how can I help you?" The same is true for more complex queries. We must be able to use the fine-tuned classification that intents and entities enable us to do to provide an appropriate and accurate response to the user. In this case, they inquired about our Toronto store hours, and the response would reflect that and contain the information the user is looking for. A dialog is simply a tree of nodes, and each node will typically handle one particular scenario. For example, here we have 3 nodes. The first one is Welcome, which handles the Chatbot prompt. In other words, our greeting when the first user arrives. Then we have a Greetings node to respond to the user greeting us. And finally, we have a special fallback node that will notify the user that the chatbot wasn't quite sure about what the user was asking. Welcome and anything else are two default nodes created for you when you first create the dialog for your chatbot. Any node you'll define will sit in between these two. But let's take a quick look at what a node might look like. You'll want to give each node a name. Watson doesn't really care about the node name, but it's useful to us, the chatbot designers, so that we can more easily organize and work with our nodes. Next, we'll have a condition that determines when the node should be executed. In this case, the node will be executed if the greetings intent is detected in the user input. The condition can be as simple as this or complex logical expression. In most cases, it will test against an intent, entity, or a combination of them. Then we have the response block, where we finally get to decide what to reply back to the user. In this case, a simple, "Hi there, how can I help you?" will suffice. This response block has many options. In fact, the response doesn't even have to be text. It could be an image or some options for the user to choose from. We can provide multiple response variations and then decide if they should be issued in the order they appear every time this node is executed or randomly from the list we provide. We can even have multiple responses where we attach a condition to each individual response within the same node. This is a great feature, and we'll definitely take advantage of it in the labs of this course. Finally, we get to specify what happens after we issued a response. Typically, we just wait for the user to say something else, and that's why that's the default action. However, other options are available, including the ability to jump to other nodes within the dialog. This is a feature that will be useful in more complex chatbots, but can lead to chatbots that are difficult to reason about if you abuse it. The execution is evaluated from the top to the bottom of the dialog. So when the user submits their utterance, the first node will be evaluated for execution. If the condition is not met, we'll move down to the second node. If this one doesn't meet the criteria either, we'll consider the third node, and so on. Essentially, we continue to evaluate nodes in the order they appear while the conditions of these nodes are false. We stop at the first node whose condition matches the user input. This is why it's important to have that anything else fallback node at the very bottom. That node has a special condition that is always true whenever all the nodes above it failed to execute. It ensures that we have a reply for the user, even if it's a simple, "I don't understand, could you try rephrasing?" Likewise, this is why we have the welcome node greeting the user at the very top. That node has a special welcome condition that is only true at the beginning of the conversation with the user. By placing it up top, we ensure that it's executed prior to any other node being considered. The fact that the condition is only true once ensures that we don't keep greeting the user every time we evaluate their input. Nodes can also have children nodes, and there are situations in complex chatbots where employing this feature enables us to create a more nuanced chatbot. Children nodes are considered for execution only after the parent node has been executed, unless some other node in the dialog explicitly jumped to a given child node. Children nodes are then also executed top to bottom, and we stop executing at the first child node that meets the condition. Watson Assistant introduced many cool new features that actually allows us to rely less on children nodes, greatly simplifying our dialog design. By the end of this course, you'll become familiar with both children nodes and the simpler alternatives you can commonly use in many scenarios. Welcome to the second video of this fourth module. The labs within this course will teach you everything you need to know about how to work with chatbots. However, before we get into the nitty-gritty details, I wanted to quickly mention a couple of guiding principles for building user-friendly chatbots. Whenever you design a chatbot, you should consider the tone and personality of your chatbot. Consider the audience and purpose of the chatbot, and then adjust the chatbot accordingly. If you are targeting a younger demographic, vanilla jokes and emojis might be appropriate. If your chatbot is for a funeral home, perhaps avoid jokes and using slang. Much like you would if you were to train a human customer service agent, you want to ensure the chatbot issues responses that are appropriate for the circumstances, whether a formal or informal tone is in order. Consider the default chatbot prompt. Hello, how can I help you? It's a default value when we first create the dialogue, so it has to be generic by design. But it's not very good, and it's the first thing I like to change in a chatbot. Let's see how we can improve it. In our case, we might change it to say something like, Hello, my name is Florence, and I'm a chatbot here to assist you with your questions about store hours, locations, and flower recommendations. This is a much more user-friendly prompt for the user. Let's see why. We start by giving the chatbot a bit of personality by giving it a name. It's no longer a random software in the ether. It's Florence. Next, we come clean to the fact that we are a chatbot. This is important because it sets the right expectation with the user. We want our chatbot to be human-like, but we don't want to falsely pretend that it's actually a human, as this will lead to disappointment for the user. Finally, we define the scope of the chatbot by guiding the user on what they might be able to ask. The worst thing a chatbot can say is a wide-open, "What can I do for you?" It's okay as a reply later on in the conversation, after you already declared the chatbot's scope. But a "Hello, what can I do for you?" off the bat is an invitation to ask the chatbot anything, and that will inevitably lead to disappointments. No matter how thorough of a job we do with our chatbot, we are not going to make it capable of answering every question it will receive. Heck, we wouldn't even be able to make such a claim if we were training a human customer care agent either. But doubly so for a chatbot. On top of the considerations we discussed so far, I'd like to leave you with 3 important rules of chatbot design. The first one is that you should avoid including yes and no in your answer. If you include them, it's very easy to give the wrong answer to the user or come across as less human-like than we'd want. For example, consider this question. We might have a free delivery intent, and we might be tempted to answer with, "Yes, it is." When the question is phrased like this, the reply works. However, if the user phrases the question differently, the same intent will be detected and the response will be issued. Only this time, "Yes, it is" a pretty bad answer to the question, "Do I have to pay for deliveries?" A much better answer is one that avoids a straight yes or no. By responding with, "Deliveries are free," for example, we correctly respond to a question expressing a request for delivery pricing information, no matter how it's phrased. Related to this first rule, whenever possible, try to incorporate part of the user's question in your response. The user will feel more understood, and the chatbot will be perceived as more intelligent as a result. For example, the user might ask us if we have a store in a given city. "We have stores in Toronto, Montreal, Calgary, and Vancouver" is an okay response as it answers the question. However, we could improve it by incorporating a bit of empathy and information provided by the user in our response. If we reply, "Unfortunately, we don't have a store in Seattle," frowning emoticon, "to date we have stores in Toronto, Montreal, Calgary, and Vancouver," we are still conveying the same information, but this time we come across are more empathetic with the user, and all we had to do is incorporate part of the user input in our response. Along with ensuring that the answer we provide to the user is correct, we should also consider its length. Nobody likes to read walls of text. Instead, people prefer to read answers that are 1 or 2 short paragraphs long at the most. If you need to convey a lot of information in your reply, you are better off linking to a page on your site where the user can learn more about the topic. Imagine a financial chatbot trying to respond to the user with the entire terms and conditions for a credit card application directly in the chat. It would be comical. Linking to the right page would be more appropriate. And since we can embed HTML in our responses, we can make such links clickable, making it more convenient for the end user. Okay, now it's your turn. By the end of this module, you should have a much better understanding of how intents, entities, and dialogue work together to allow chatbots to provide useful answers to the end user. In the next module, we'll discuss deployment. And finally, in the last two modules, we'll look into more advanced features that enable us to create smarter and more useful chatbots.